Hi everyone, good day. I hope you are doing well. Welcome to today's class. And today I'm going to focus on one sample t-test. In my previous videos, I mentioned that for you to know the results of your collected data, you can pass them through a number of tests. And one of them that we're going to look at today is one sample t-test. We'll look at the other ones in the subsequent videos. This is the first part of the one sample t-test, which is going to be conducted in the Excel. There is another version which I have also put out there. You can check it out using the SPSS software. So without wasting time, let's go into it. So if you want to conduct a one sample t-test, I have an example here where there is a national average of engineering test score, which is 5 nationally on the average. The engineering test score is 5. And we have sampled 15 students from one school in a certain country, 15 students. And these are their scores. So you can see the scores of the students here, 15 students. They are all here. Now let's look at how to get the one sample t-test done. And then we'll also make a decision out of it. So the first thing that we can do is that we can hypothesize, or we can put out our hypothesis. And our hypothesis is going to be that the null hypothesis is going to be that we assume that there's no difference from what these 15 students are going to give to us on the average. These 15 students, their scores will not be different from the national average. So it's going to be 5. The null hypothesis is going to be, the mu is going to be equal to 5. But on the alternative, we assume that these students, their average will be different from the national average of 5. Now let's go get into it, do the computation and get the results. So if we want to get a one sample t-test done, in order to make a decision whether we are going to reject the null hypothesis or opposite, this is how we'll go about it. The first thing is we need to know the sample size. What's the number of students that we are sampling here? So to do this, there is a function in the Excel which is called count equal count. And you put it on the number of test scores, and that will give you 15. So the 15 here is giving us the opportunity to know that the test score are coming from 15 students. In other words, the 15 students that we have sampled. Then we can determine what we call the degree of freedom, which is the second step. So for us to get a degree of freedom, we just take the number of students that we have sampled, which is 15. Then we take 1 out of that. And that's going to give us 14. Then we can also determine the average. In other words, the sampled 15 scores of students, we can get their average. How do we get the average? Very simple, equal sign. You bring an average, and then you just put your cursor on the 15 scores, and that will give you their average, which is 7. Now we can also determine the standard deviation of these 15 sampled scores. So to get that, we put a standard D here, and then we just look for the standard deviation of these students. Yeah. And then we can also go ahead and find what we call the standard error. The standard error, for us to make it very simple, if you check the T statistic formula, the standard error is what you can see here, which is the denominator, which is simply the standard deviation divided by the square root of the sample size, which is 15 in this context. Square root of that, and that will give us this. Now the population mean, which we normally most people mention or use the term mean. So the mean in this context is the 5, which is the national average. And then we go ahead to compute the t statistic. So using this formula, the x bar is our mean of the sample, or the sample mean, minus the mean, which is the national average of the engineering test score, divided by the standard error, which we have already computed, which is the denominator. And that will give us this. For us to get the p-value, it's very simple. So what we can do is we put the equal sign here, and then t, this, the x represent the t statistic, and then the degree of freedom, which is 14, comma, then here we have to determine the tail. The tail here will depend on whether we mentioned we are looking for a greater. We want to determine whether these 15 students, their score is greater or less. But in this context, we will take a two tail because we are just assumed that it could be greater, it could be less, it could be whatever. Yes, that is not equal. So we'll take the two sample, two tails distribution. Then once we take that, put an equal sign, and that will give you 0.04181. So the question is, what decision are we making? So according to the standards and according to what we know from statistics, when your p-value is less than 0.05, which in this context, we assume that the significance level is 5.5%. If it's less than that, which in this context is less than that, is less than 0.05, this p-value from our computation is less than this, then we can reject the null hypothesis. That means these 15 students, their sample mean is not equal to the national average. Rather, it could be greater or less. Okay, so here we accept the alternative hypothesis. So first we'll reject. So the most important thing is to reject the null hypothesis. Reject the null hypothesis. And then if you reject the null hypothesis, then you fall into the alternative hypothesis, which says that our 15 sample students, the average could be higher or could be lower than the national average. Thank you very much for watching this video. Please make sure you subscribe and also you watch the other videos on my YouTube channel. Thank you very much.